Now I will explain about MEMS capacitive sensor. The operating principle of the design MEMS capacitive sensor is based on the change in permittivity upon the gas elevation using a gas sensitivity material. Now, as we can see the figure above, it a cross section of capacitive sensor, and the figure below is top view of capacitive gas sensor. Uh, there are two electrodes, and the above electrode is a sensing film. And there are two equations whether to analyze the relative effect of the different design parameters on the sensitivity.
Assalamualaikum and greetings. My name is Muhammad Daniel Shabin Norden and I will be presenting about MEMS fabrication simulation for layout and material database of capacitive sensor. As you can see on the top left corner, which is the layout for the capacitive sensor, and for the material database there will be 5 materials that are used for this capacitive sensor, which is p-type silicon, oxide, titanium, gold and nitride. So for the p-type silicon, the elastic modular is 1.79 exponent 0.11. For the Poisson ratio is 0.22, and for the density is 2330. For oxide, the elastic modular is 6.9 exponent plus 0.10. For the Poisson ratio is 0.17, and for the density is 2200. For titanium, the elastic modular is 1.138 exponent plus 0.10. For the Poisson ratio is 0.312, and for the density is 4.43. For the gold, there will be only elastic modular value, which is 8 exponent plus 0.10. And lastly, for the nitride, the elastic modular is 85, the Poisson ratio is 0.25, and the density is 2.3.
I will talk about the MEMS fabrication simulation for the process definition of 3D model. We choose to use 5 types of material: nitride, gold, titanium, oxide, and silicon substrate. There are 8 steps of process definition. First one is substrate wafer, second raw oxide, third sputtering Ti, fourth sputtering Au, 5 etching Au, 6 etching Ti, 7 etching oxide, and the last one is deposit nitride. From the all 8 steps, we can see the final 3D model and the final cross section.
As you can see in the analysis system, we have successfully import the IGL file from MEMS Pro software into geometry of ANSYS simulation, and we also update the engineering data same as on the material that we use in MEMS Pro software. Next, we do the cross-section of the model as we can see on the section plate in the geometry. It used to check the material is laid correctly on the model. To run the analysis simulation, we'll use pressure and feed support on the model as an input to test and get the result as we can see here. Pressure is given in the middle of the body surface. The body material sustains that pressure through deformation, which causes stress in the material, and the entire model comes to a state of equilibrium for a static structural model. Next, we have get the output of simulation result of total deformation, minimum and maximum strain, and minimum and maximum stress. Total deformation is a deformation option that allows you to examine all of the model deformation result in 3 dimensions, which is X, Y, and Z. Moreover, there are 6 different pressures have been applied on the middle of the model, which is 0, 500, 1000, 1500, 2000, and the lastly is 2500. By comparing all the results in graph 1, 2, and 3, we can see that if pressure is increased, the total deformation, maximum stress, and maximum strain also increase.
Assalamualaikum and hi, my name is Muhammad Faiz bin Zulkifli. I will be present slide for MEMS capacity sensor for industrial air pollution. Okay, with the coming of the industrial revolution, humans were able to advance further into the 21st century. Technology developed rapidly, science became advanced, and the manufacturing age came into view. With all of this came one more effect, industrial pollution. Earlier, industry was small factories that produced smoke as the primary pollutant. However, since the number of factories were limited and worked only a certain number of hours a day, the level of pollution did not grow significantly. But when these factories become full-scale industries and, manufacturing units, the issue of industrial pollution starts to take on more importance. So the next slide is Sustainable Development Goal. There are 5 Sustainable Development Goals that are related to this project. Okay, poor air environment is a global environmental challenge. Improper waste management will create numerous environmental issues such as water pollution, air pollution, and health problems. A smart gas monitoring system is proposed by utilizing a MEMS capacitive gas sensor. The smart gas monitoring solution will detect toxic or explosive gases and measure gas concentration. Gas sensors are employed in factories and manufacturing facilities to identify gas leaks and to detect smoke and carbon monoxide in homes. Besides, it also includes the Wi-Fi module to take necessary action immediately by sending an alert SMS to the owner. That's all. Thank you.